Hey guys, I'm here back with another math video. Today we're going to be doing 2016 AMC 12B problem 25 since AMC is coming up. So take a look at the problem, see if you can do it, and pause the video if you need to. Without further ado, we're going on to the solution. So the first thing we notice about the problem is that, it's a sequence problem, so we can actually just try we can try to write it out. There's nothing wrong with that. So the first term is 1, the second term is 2 to the 1/19th. It's easier with exponents. Third term is 1 squared times 2 to the 1/19th, so it's just 2 to the 1/19th. The fourth term seems to be 2 to the 1/19th squared, so the second term squared, times the third term, so it's 3/19th, 2 to the this thing squared times 3/19th, that becomes 2 to the 5/19ths. And we look at this and we sort of see, like, there's this pattern. Maybe we can make this easier instead of writing all these freaking 2's and all these exponents. So let's think about this. What does it mean that the product a1 through a2 that multiply all these together is an integer? Well, we certainly see that 1 times 2 to the 1/19th is not an integer. 2 to the 1/19th is not an integer. When you multiply all these together, it's not an integer because there's still 2 to the something over 19. However, if we multiply all these together, notice that we add the exponents. We add the exponents together. So if we multiply just this sequence together, we get 2 to the 10 over 19. So we're adding the exponents. And notice that each term we go in the series, the next term we're going in the series, we're taking this exponent, multiplying it, but we're taking the, let's say this is the next term, right? We're taking this exponent, multiplying it by 2, and adding it to this exponent to get the next one's exponent. So 3 over 19 times 2 is 6 over 19, plus 5 over 19 is 11 over 19. Mainly because when you square this number, you're essentially doubling the exponent. And when you multiply it by this number, you add the exponents together. And we want the exponent to be an integer, right? So why don't we actually just make a sequence of exponents? That seems a lot easier. So 2 to the 0. Remember, 2 to the 0. This is 2 to the 0. So it's 0, 1 over 19, 1 over 19, 3 over 19, 5 over 19, 11 over 19, and so on. The next one in the series will be, so let's say this is Bn. This is a sequence of Bn. So Bn is actually equal to Bn minus 2 times 2 plus Bn minus 1. Just the way that exponents work. Now I'm not trying to do this formally, I'm trying to do it the way I tried to solve it. Because on the AME you don't really need to write things out formally, you can just sort of bash it out. So we have this sequence, and in order for this sequence to qualify as the product of a to the k being an integer, all the up to here to the end of the sequence, they have to add up to an integer. And if they add up to an integer, that means 2 to the, that means when you multiply these together, all the exponents are added together. So the product, if this is an integer, this will be 2 to the integer, which is an integer. So if we add these up, that's equivalent to multiplying these. And if this is an integer, that means that's equal to 2 to the integer, and that's equal to an integer. So that works. So we just want this sequence to add up to an integer, and that seems much easier than what the question is initially asking. I think we can make the sequence even easier. So let's say this is equal to an integer k. We multiply both sides by 19 and we get 0, 1, 1, 3, 5, 11, dot dot dot. If you add them all up, it's equal to 19k. So we just want this to be multiple of 19. Now this is hard. Like, where do you know? How do you know where's the spot when it gets to a multiple of 19? Should you calculate it out manually? You don't have to, really. You can actually just write it out, because the reason for this is, look, the answer choices are 17, 18, 19, 20, 21, right? That means you only need 17 terms. You don't really actually have to calculate it. You just need to write out 17 terms. There's probably a way to calculate it, but you're in a competition. You really don't care how you get to the answer. You might as well just write it out. It's easier. So let's write it out. So 0, 1, 1, 3, 5, 11, and then the numbers seem to be getting pretty big. 5 times 2 plus 11 is 22. Right. Yeah, we can make this a bit easier. I mean, sorry, not 22, 21. 20. We just want this to be a multiple of 19. So we don't actually need to use 21. We can actually just use 2. We can just take a 19 out of there. Because as long as this is a multiple of 19, we're fine. And if we just take 19 out of there, then the mod, we want this to be 0 mod 19, essentially. 0 mod 19. And if you take 19 out of any one of these numbers, that doesn't really change the mod of the number, the mod of the sum of these numbers. So we can actually just, any number is greater than 19, we can just shave down to like the mod of them, mod of a 19. And it's pretty cool because we can actually yeah, we can actually just use this, because we can actually just use this number in when calculating subsequent terms. So this just becomes 11 times 2 is 22, 24, which goes to 5. And here's why, because since the mod of this number in terms of 19 doesn't change, then that means when you add something to that, when you add 2 times this to that number, the mod of the sums don't change either. So not only does the mod of this summation up to that term doesn't change in terms of 19, but the mod 19 of when you're making subsequent terms doesn't change either. So if we actually just use 21, that would be 22 plus 21, which is 43. Notice that this is still 5 mod 19. It doesn't change. That makes our job substantially easier. So we can just keep doing that. And if you extend the sequence, 14, 8, 17, 14. Careful now. This is our 17th term, and we have to start checking now. We don't even need to check before this, because we already know that's not going to be our answers. We only need to start checking on the 17th term. That's what makes this question so easy, actually, in my opinion, for a 25th problem. You just need to check the 17th term. And it turns out the 17th term actually works. If you add all this stuff up to here, you'll find you get 133, which is equivalent to 0 mod 19. So this is divisible by 19. So this sequence up to 17 will be an integer. So this will be 2 to the sum integer, and then everything will work out. So 17 is the answer, actually. Pretty cool question. I didn't really solve it the formal way that you're supposed to solve it, and that's because I want you guys to start practicing what it's going to be like on a real test, and try to find these cheating methods, so you don't really have to do as much work as you think you do. I hope you enjoyed this video, and see you next time.
I think that's equal to 2 cosine squared